Hello everyone, I'm Kiran Dewari. I'm going to present a critical review on a research topic as part of Assessment 3 for Bionanotechnology. The paper that I've chosen for this critical review is Antimicrobial Second Skin using Copper Nanomys. This is a joint research project conducted by Japanese and Korean researchers from the University of Tokyo and Korea University of Science and Technology. This article was published in PNAS Journal in mid-2022 and was conducted to see the viability of nanomist structure embedded with copper nanoparticles in prevention of cross-infection and for creation of second skin alternative that causes less impedance than a glove. Before moving on with the presentation, let's firstly look at what this presentation contains. We will firstly look at some background information regarding the article and some key information that we need to have to understand the research. Secondly, I will go through the summary of the research, including its methods, finding, and conclusion. After that, I'll provide a critique of the research paper based on its scientific approach and what I found to be interesting. Finally, I'll give a conclusion of the presentation by including some future recommendations, and I will also provide a list of articles and further reading materials that you may go through if you found the topic interesting. Now let's move on to the background. To understand the research fully and to see its significance, we need some basic background information about some key components of this research. The research focuses on using copper embedded in a nanomist material to create a second skin that can prevent cross-infection by acting not only as a physical barrier, but also as an antimicrobial coating. Let's begin with copper and why it was selected. Copper has long been used as an antimicrobial agent and has been shown to have great efficacy in dealing with microbes. Copper has been used in ancient times for storage of food and for winemaking purposes. Currently, copper is used in hospital beds, for handrails, and for doorknobs. Lots of research has been conducted in copper and how it is effective in killing bacteria and viruses. Copper nanoparticle is even more effective than copper in terms of antimicrobial properties. This is because of the large surface area of the copper nanoparticle, along with the electrically charged particle that can create cellular lysis of bacterial cell when attached with the copper nanoparticle. Thirdly, let's focus on nanomys. Nanomys is a mesh-like structure that is made up of nanofibers that can be used to deliver nanoparticle onto the skin. The nanomys can be used to deliver drugs or other substances to the skin in a controlled manner. In this study, nanomys is used as an adhesion that has been used to provide a surface for the copper to bind to before being transported to the skin. Um, Fourth, let's focus on cross-infection prevention. Cross-infection prevention and the need for cross-infection prevention has been highlighted by COVID. Hospital-acquired infections caused by bacteria, viruses, and other type of pathogens can be serious and life-threatening. The risk of hospital-acquired infection can be reduced by following proper infection control procedures such as hand hygiene and environmental cleaning. With all this in mind, we can now understand the significance of study and why this research was carried out. Hospital-acquired infection and MDR pathogens are of great concern in hospitals where cross-infection are quite common. While gloves and other physical barriers exist, these only provide a barrier for the pathogens and cannot perform antimicrobial activity. Copper, especially in its nanoform, is a potent antimicrobial with potential to prevent such infections. Understanding the viability and effectiveness of a second skin solution can further help research in this field. Moving on to the summary of the research, we will discuss about the methods, results, and conclusion. In results, we will focus on antimicrobial assay and different physical characteristics that were studied. Firstly, focusing on the fabrication and application of the mesh, researchers in the study created a polyurethane nanomesh using electrospinning and coated it with a layer of copper nanoparticles. They transported this mesh on a PVA nanomesh and dissolved it using water to get the mesh attached to the skin. Detailed video has been provided as supplemental evidence for adhesion process, while the nanomist preparation has been done as previously stated. Other methods, including antimicrobial testing, toxicity testing, thermal characterization has also been described in detail, but will not be discussed in the video. Moving on to the result of the study, it can mainly be classified in two sections, antimicrobial properties and second skin properties. Firstly, looking at the antimicrobial properties, copper nanomist was able to perform it with great efficacy. As shown in the first figure, E. coli was used as model gram-negative bacteria, and the total number of bacteria dropped by 99.9% within 1 minute of contact with the nanomist. This was due to the lysis of cell structure as shown in scanning electron microscopy image of the second and third figure. The researchers were also interested in the effect of nanomist in viral particles and analyzed the viability of influenza virus by performing plaque formation assay. It was seen that compared to polymer nanomist alone, the copper embedded nanomesh was much more effective in neutralizing the viruses. 99.9% of the viruses were killed within 10 minutes of contact, resulting in a decrease in the viral load as shown in the second diagram by the red line. As the researchers were concerned with second skin properties of the nanomesh, they analyzed the structure against artificial skin and other alternatives. It was seen that nanomesh material was able to preserve surface details which were completely lost during the copper film and glove alone. The article also mentions that researchers tested this by performing successful fingerprint recognition using mobile phone while using the nanomesh material. Furthermore, cross-infection prevention was assessed by handling various items of daily use using a glove and a nanomesh. It was seen that nanomesh was effective with 100% efficacy of the time in preventing cross-infection without impeding normal functioning and comfort. Finally, the researchers also compared how the nanomesh compared to other commonly used items in terms of comfort. It was seen that the nanomesh was effective in forming a waterproof barrier as shown in the first figure, but still remained permeable enough to relieve humidity from the skin to prevent uncomfortable feeling that is often associated with gloves. The article mentions that this could be effective in solving the problem of eczema that is commonly associated with long-term excessive use of gloves. The article ends with the conclusion that copper nanomesh provides effective antimicrobial barrier that can be used to prevent cross-infection and to limit bacterial and viral transmission. The researchers were also concerned with preserving some of the key functionality of the skin, like heat transfer, humidity, and sensation, that is often impeded during the use of gloves. They concluded that nanomesh material can be useful as it showed skin-like properties and functioned properly in this test. They have also mentioned that further study of the nanomesh is essential before commercialization of the nanomesh can be explored. This includes study on concentration and different metal options other than the copper that was studied in this paper. After the brief overview of the research, now let's look at a critique of the research and what I found to be interesting. And we will look at the common critiques and methods. We will see if anything could be improved and what the originality of the work is and what its impacts are. Methodology of the research is scientifically sound and appropriate. The authors have not only made sure that they have included controls for copper, they have also included the nanomesh and gold to see how effective copper nanomesh is. For example, in this diagram, which has been taken from the supplemental data, shows how copper nanomesh was able to kill 99.9% of bacteria within 60 seconds, as opposed to others which struggle with the growth of E. coli. This allows them to make sure that the bacterial control is in fact due to copper and not any other chemical that is present in the nanomesh, like the polymer itself, or due to the nature of the nanomesh that has been achieved during its fabrication and creation. Here we can see the researchers have also tested for bacterial growth against a number of other commonly used antimicrobial metals, and they have also experimented with the density of nanomesh material produced by using electrospinning. This provides essential information to determine what is actually working and how it's working. For example, the second diagram shows that high density copper nanomesh is more effective than low density ones. The researchers have hypothesized that this may be due to the large surface area of the copper nanomesh particle stuck in this condition. In terms of originality, the article is quite unique. A search in PubMed database for the term skin nanoparticle copper yields 165 results. Tightening these parameters to focus on the studies that focus on the second skin aspect would drop the number even lower. It can also be seen that a lot of the papers in the topic are quite recent. I would classify this paper as a seminal paper as it has attempted to study a new topic that has not been extensively studied. It has used aspects that have been previously studied, such as nanomesh, copper nanoparticle, and second skin, but combining all of them and proposing it as a solution for cross-contamination is quite unique. Despite the originality, or maybe because of it, the article has not been very highly cited. Only 4 papers have cited it when looking up in Google Scholar. Despite its low citation, the paper has a decently good reach. Just over 2,000 people have downloaded this article from the PNAS website. Extensive data about the viewership in other portals is not available. PNAS, or Proceedings in National Academy of Sciences, is a peer-reviewed journal with an impact factor of 12.78. This means that papers published in this journal go through an extensive review process, and it likely means that the study has been conducted without any shortcomings and the research is sound in most manners. I could only identify 3 issues with the study. The researchers conducted the experiment in triplicates. I believe it could have been a bit more extensive. The area that they focused mostly is the fingertips. However, medical application would require it to cover the full hand. Furthermore, authors have not extensively focused on long-term toxicity and stability of using copper nanomesh. Despite these limitations, I believe the study has been conducted in great detail, and researchers have attempted to answer most of the common issues and have addressed some of the shortcomings as topics for future research. They have included controls not only for the external factors but also for internal factors that may affect this study, like the nanomesh structure without copper. In addition, they have also shown that the nanomesh can in fact act as a second skin as it preserves the skin's natural properties like humidity, temperature, and morphology. Future studies could focus on studying how this can be improved by increasing the coverage or making it more adherent. Thank you for sitting through the presentation. I hope you all enjoyed it as well. These are some sources that I found useful by performing this critical review. Please let me know if you have any suggestions or criticisms and on what I can do.